This discussion introduces the definition for vertical and horizontal asymptotes. As we know, an asymptote is some relation or function that a function will mimic. But we're going to talk about the definition of a vertical asymptote and a horizontal asymptote. We have right here the definition of a vertical asymptote. The vertical line, x equals a, is a vertical asymptote of a function f if any one of four limits is true. If the limit of the function as x approaches a from the right equals either positive or negative infinity, or if the limit of the function as x approaches a from the left is equal to positive or negative infinity, then x equals a is a vertical asymptote. What about a horizontal asymptote? Well, a horizontal line is described by an equation y equals a number. So the horizontal line described by the equation y equals b is a horizontal asymptote of function f if the limit of the function as it goes out to either positive or negative infinity equals b. If as we go out to positive infinity or negative infinity, as x approaches those really large or really small numbers, f of x is approaching b, then y equals b is a horizontal asymptote of the function. Okay. Let's look at a particular example. F of x equals the rational function 2x divided by the quantity x minus 1. And we want to show that y equals 2 and x equals 1 are asymptotes of f of x. Okay, if y equals 2 is an asymptote of f of x, then the limit of f of x as x goes out to either positive or negative infinity. If we can show that either as x approaches infinity or as x approaches negative infinity, if the limit turns out to be 2, then y equals 2 is an asymptote. So let's look at positive infinity. This limit is equal to the limit of, we're going to multiply our argument by a judicious form of 1. We're going to multiply by 1 over x divided by 1 over x. So this is an expression that equals 1, so it shouldn't change the value of our argument in our limit. Now, multiplying 2x times 1 over x, we get simply 2. Multiplying x minus 1 times 1 over x means we're going to distribute the 1 over x times x minus 1. We'll do that distribution. And we get 2 over 1 over x times x is just 1, minus 1 times 1 over x is 1 over x. Now we will directly substitute in the infinity. We get 2 over 1 minus 1 over infinity. But remember, we talked about the limit of the reciprocal function as it goes out to infinity. That's going to approach 0. 1 divided by really, really large numbers gets so negligible we call that 0. So we end up with 2 over 1, which is 2. So we found that the limit as x goes to infinity of our function equals 2. Therefore, these three triangle dots means therefore. Therefore, y equals 2 is a horizontal function is a horizontal asymptote of our function. What about x equals 1? We were also supposed to show that x equals 1 is a asymptote of the function. Well, that's a little bit trickier. We're going to have to look at the limit as x approaches 1 of the function and show that it's equal to either positive or negative infinity. We can approach 1 from either the left or the right. So we have to look at one of those limits, and we have to get either one of those one-sided limits to get either positive or negative infinity to show that that's an asymptote? Well, let's look at the limit of f of x, which was 2x over x minus 1, as we approach 1 from the left. Now, we won't try to do this, we won't try to prove this limit. We'll just convince ourselves that it's either infinity or negative infinity by looking at a table of the function. Let's think about values that are approaching 1 from the left, like 0.9. If we put in 0.9 into the function, let's see, we'll get 1.8 in the numerator, but we'll get a negative 0.1 in the denominator, which will give us a negative 18. If we put in 0.99, which is much closer to 1 from the left, let's see, 2 times 0.99, that'd be 1.98, but we'd be dividing it by a negative 0.01, so we'd get a negative 198. If we evaluated it at 0.999, we'd see that it'd go up to 1,998. So we become convinced that the closer we get to 1, the smaller the value of f of x, and that this limit actually does not exist because the curve is headed towards negative infinity. And if that's true, then x equals 1 is a vertical asymptote of the function. And it's a vertical asymptote because it meets the definition, precisely because it's a vertical asymptote because we found that the limit, as x goes to 1 from the left of the function, equals negative infinity.